So what is the meaning of gravitation? It is nothing but the force of attraction between any two bodies in the universe by the virtue of their masses. Gravitational constant is denoted by G and gravity is denoted by small g. From center, let R be the radius of the earth and this distance is R minus d. Hello everyone, welcome to session 1 of chapter 8, Gravitation. This is Swati from Department of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. So gravitation, the word which is familiar to all of us. We all have at least an idea about this term called gravitation. So in this chapter, we are going to study about the laws of gravitation, why it is called as universal law, how does the force of gravitation varies when we go above the earth's surface, below the earth's surface, and many more interesting concepts. So let us begin with the introduction part of gravitation. What do you mean by gravitation? Why we have to study about it? So to get the answer for all our questions, we all know that all the planets are revolving around the sun in their own orbits. They do not collide with each other. They do not even go and collide with the sun. That is because the force between sun and other planets, and that force is nothing but the gravitation. And the force that helps all of us to walk on the earth, or the reason that we never fall though the earth rotates, everything because of the force of gravitation. So let us now theoretically find some answer to all our curiosities and let us get some knowledge about this variation of gravitation from surface to surface and many more interesting concepts. So what is the meaning of gravitation? It is nothing but the force of attraction between any two bodies in the universe by the virtue of their masses. So any bodies that have their masses, there exists a force of attraction between those two masses, and that force of attraction between any two masses, we will call it as gravitation. So why it is called as universal law of gravitation? So Newton proposed this law of gravitation and it is also called as a universal law of gravitation. What is the reason? It is called as universal because this law is applicable for all the bodies which are present in the universe, and hence it is called as universal law. So it is also nothing but a Newton's law of gravitation. So what is the statement? Newton's law of gravitation states that the gravitational force of attraction between two bodies is always directly proportional to the product of the masses. The masses of what? Masses of two bodies. Say for example, if we consider two bodies which are having masses, the gravitational force of attraction between these two masses is directly proportional to the product of their masses and inversely proportional to the square of distance between them. And this force acts along the line joining the two bodies. Say for example, I have two masses here, M1 and M2, say for example, and it is separated by a distance d. There exists a force of attraction between these two masses. So according to Newton's law of gravitation, the force of attraction that exists between two masses is always directly proportional to the product of the masses, that is M1 and M2, and it is inversely proportional to the square of the distance between them, that is d square. And here the proportionality can be replaced by equating this with a constant, and that is g into m1 m2 divided by d square. So what is g? G is nothing but the universal gravitational constant. So this value of g does not depend on the size or shape of the bodies. It does not depend on the nature of medium where the masses exist. It does not even depend on the temperature, pressure and any other physical conditions. So this g is called as universal gravitational constant. We can even write the SI unit of G. From this expression, we can write G is equal to F into D square divided by M1 and M2. So what is the SI unit of gravitational constant? We can also write, so force Newton, and D square is nothing but meter square. M1, M2 are the masses. So we have kg into kg, that is kg square. So we can write it as Newton meter square per kg square is the SI unit of G. So this is all about the gravitational constant. So now let us learn what is gravity. So far we have learnt about G, that is gravitational constant. So we are very much familiar with another G, that is small g, acceleration due to gravity. So we have come across the value of G in solving the numericals, in substituting many of the expressions. So the value of G, that is acceleration due to gravity, is known for us, that is 9.8 meter per second square. But what is that? So why do we call it as acceleration due to gravity? So to answer all these questions, we must know first about the gravity. What is gravity? How it is different from gravitational force? So the gravity is nothing but a force of attraction exerted by the earth on a body. So it is nothing but the force of attraction that exists between earth and another body. So we'll call it as gravity. And next, acceleration due to gravity. As I said, why the name acceleration due to gravity? Because it is nothing but the acceleration produced in the motion of a body due to gravity, and hence the name acceleration due to gravity, which is denoted by a letter small g. Now let us derive a relation between acceleration due to gravity and the gravitational constant. The relation between capital G and small g, now we are going to derive. So to derive this, let us consider a mass. So here in this figure, M is a body which is present on the surface of the earth, and capital M is nothing but the mass of the earth. So here R is nothing but the radius. Say for example, so here earth is one body and the small m is the another body. As we all know, there exists a force of attraction between two bodies, that is between capital M and small m, which means the force of attraction between the earth and an object which is present on the surface. So now from Newton's law of gravitation, as we all know, F is equal to gm divided by r square. This is from, I told you about the force of attraction between two bodies is directly proportional to the product of their masses and inversely proportional to square of the distance between them, and here proportionality is replaced by a constant, that is g, and m1 m2 divided by r square. Here m1 m2 are nothing but the mass of the earth and a body, and this can be written as gm divided by r square. So now what is F? F is nothing but the weight, and F is equal to mg, we can substitute. So in the place of F, I am substituting mg, which is equal to gm m by r square. So from this I can cancel these two m, and I remain with g is equal to gm divided by r square, where the capital G is nothing but gravitational constant and the small g is nothing but acceleration due to gravity. So this is how they are related with each other. So acceleration due to gravity is equal to gm divided by r square is the relation between these two terms. So now let us derive an expression for acceleration due to gravity at a point above the earth's surface. Say for example, on the earth's surface we have derived just now. Now what happens if the point is above the earth's surface? How does the gravity varies? How does the value of acceleration due to gravity varies? Whether it decreases or whether it increases, we have to derive. So let us derive it now. So here again I have considered an earth. Say for example, this is an earth of mass m. Now, there exists another point here which is above the earth's surface. I'll call it as point A. So here, h is nothing but the distance at which point is present from the surface. So B is nothing but the point on the surface. This is the earth's surface. B is the point on the earth's surface. A is the point which is at a distance h above the earth's surface. So here I have taken on the earth's surface the value g, that is acceleration due to gravity, and above earth's surface at certain height I have taken it as gh. In this figure, r is nothing but the radius and c is the center. We all know the relation between acceleration due to gravity and the gravitational constant, that is gm divided by r square. Just now we have proved. So now let us write this acceleration due to gravity expression for a point which is at a distance of h above the earth's surface. So that is gh is equal to g into m divided by, and the distance is nothing but from the center it is r plus h. So it is r plus h the whole square. So let us take it as equation 1 and this as equation 2. So let us now simplify this expression by dividing equation 2 by 1. So what do we get? GH is equal to GM divided by R plus H the whole square divided by G, which means GM divided by R square, or we can write it as GM divided by R plus H the whole square into R square divided by GM. So now from this we can cancel these two terms and we remain with R square divided by R plus H the whole square. So from this we got the expression. So now we get GH divided by G is equal to R square divided by R plus H the whole square. Or from this we can write GH is equal to, we just need an expression for acceleration due to gravity at a point above the earth's surface, and that is GH. So I just want the expression for GH. So G will get cross multiply with this and I'll get G into R square divided by R plus H the whole square. So this can be written as GH is equal to G into R divided by R plus H the whole square. Or we can write it as GH is equal to G into R plus H divided by R to the power minus 2. This can again be written as GH is equal to G into dividing these two terms with the denominator 1 plus H divided by R to the power minus 2. So by expanding this with the help of binomial expansion and by neglecting the higher order terms, we will get the expression GH is equal to G into 1 minus 2H divided by R, and this is the expression for the point which is present above the earth's surface. This is the expression for the acceleration due to gravity at a point which is above the earth's surface at a distance h. So now we can conclude variation of acceleration due to gravity above the earth's surface by considering one of these expression. Now carefully observe this expression. So here the acceleration due to gravity GH value increases as the value R plus H decreases. But here R plus H is there, which means R plus H. As this value increases, the acceleration due to gravity value will decrease since they are inversely proportional to each other. Now, as the point which is present above and above the earth's surface, which means if this value increases, the value of G will decrease. So from this equation, we can say that as we go above and above, the acceleration due to gravity decreases. So now let us derive an expression for acceleration due to gravity at a point below the surface of the earth. What happens to acceleration due to gravity as we go below the earth's surface? So let us consider this as this sphere as earth, and this is a point A on the surface of the earth, and the value of acceleration due to gravity here is G. And if we consider another point which is located at certain depth, I'll call it as B, and here the acceleration due to gravity at depth, and it is denoted by GD. And here from center, let R be the radius of the earth, and this distance is R minus D, because D is nothing but a depth. So total distance is R. We are now considering the acceleration due to gravity at point B, and hence it is R minus D. Here in this figure, M is mass of the earth and M dash is the mass of the another sphere we considered at certain depth. So now let us write the acceleration due to gravity at point A. So at point A, acceleration due to gravity expression is nothing but G is equal to Gm divided by R square. We have already derived it. Now similarly we will write the expression, that is acceleration due to gravity at point B. So at point B means a point which is located at certain depth. So that is GD equals, here the mass of this small sphere is m dash. So I'll consider it as G into m dash divided by, the distance is nothing but R minus D. So R minus D the whole square. This is my equation 2. So let us now divide these two equations for simplification purpose. That is dividing equation 2 by 1. I will get GD divided by G, LHS terms, which is equal to GM divided by, and here in the denominator I have R minus D the whole square. Here G value is nothing but Gm by R square, but we have to take the inverse since it is in denominator. So I will write it as R square divided by G into M. But here it is M dash because I have considered the sphere which is at certain depth. Now in this we can cancel G and G and I remain with, so we get GD divided by G is equal to M dash R square divided by M into R minus D the whole square. So here M is nothing but the mass of the earth and M dash is nothing but the sphere we have considered below the earth's surface. So now let us first write the expression for mass of the earth, but how to calculate? So that can be written with the help of density formula. We know density is nothing but mass divided by volume. So now from this we can write mass of the earth is nothing but the density into volume. So what is volume? Here earth we have considered it as sphere. So volume of the sphere is nothing but 4 by 3 pi r cube. So let us consider this as equation 3 and this as equation 4. Similarly, let us consider another sphere which is at a depth of D below the earth's surface. So the mass m dash is nothing but density into volume. So density into 4 by 3 pi r minus d the whole cube, and let us consider it as equation 5. So now let us substitute this equation 4 and equation 5 in equation 3. So substituting in the place of m the value, that is density into 4 by 3 pi r cube, and in the place of m dash it is rho into 4 by 3 pi r minus d the whole cube. So what do we get? Let us simplify by substituting these two in the equation 3. So substituting and simplifying, we will get GD divided by G, which is equal to R minus D divided by R. Or we can even write it as GD is equal to G into, dividing this with the denominator, we will get 1 minus D divided by R. So this is the expression for acceleration due to gravity below the earth's surface. So this is the expression for acceleration due to gravity at a point B, which is there below the surface of the earth, which is nothing but the value of acceleration due to gravity decreases as the depth increases, which means if we go below and below the earth's surface, the acceleration due to gravity decreases. As the depth increases, acceleration due to gravity decreases, is the conclusion what we can give from this expression. So in today's session, we have learnt about gravitational constant, force of gravitation, acceleration due to gravity, and the variation of acceleration due to gravity above and below the earth's surface. In our next upcoming sessions, we will learn many more interesting concepts. Until then, all of you keep learning. Thank you.